Here we have some problems in scientific notation. And if you haven't heard of this before, scientific notation is just a handy way to write really big or really small numbers. Scientists are dealing with really big or really small numbers all the time, and it gets tiresome to write all the zeros. So this is kind of a shorthand way that gets rid of a lot of the zeros. The way you do this is you move the decimal point of the number so that there's just one integer to the left of the decimal point. So if we start with this number 256,000, we're going to move the decimal point all the way over until it just says 2.56. And then we're going to multiply it by some power of 10. Actually, let me show you a simpler example. Let's say we had the number 200. We know that 200 is 2 times 100. And 100 is 10 to the second power. So 2 times 10 to the second power is the same thing as 200. This is in scientific notation. Now, you probably know off the top of your head that 100 is 10 to the second power, but you might not know off the top of your head other powers of 10. So there's a handy shortcut way to do this. You just count the number of spaces you have to move the decimal point. So in 256,000, the decimal point's here to begin with, and we're going to move it to the left and we'll count. So 1, 2, 3, 4, 5. And now I've just left one digit to the left of the decimal point. So I have 2.56, and I've moved it 5 spaces. That means I multiply it by 10 to the 5th power. So our answer is 2.56 times 10 to the 5th. With the 200 example, decimal points here, we move it 1, 2. So that's 2 times 10 to the 2nd. Let's try another one. This one is 2,999,000. So we're going to write that in scientific notation. Let's count the decimal point spaces. So 1, 2, 3, 4, 5, 6. So this is going to be 2.99 times 10 to the 6th power. All right, let's try another one. Now this is a little bit different. It's going the other way. We've got a really, really small number. So instead of moving our decimal point over to the left, we're going to move it to the right. And when we do that, the powers of 10 are negative. But otherwise, we do it in pretty much the same way. Let's go ahead and move this. 1, 2, 3, 4, 5, 6, 7. And I stop here. I've got 7.1 now. That's what I want, one digit to the left of the decimal point. I moved it 7 spaces, so this is 7.1 times 10 to the negative 7. All right, we've got one more problem, a little bit trickier. This one says the population of Mexico in 1997 was 97.6 million. Write the number in scientific notation. Well, they haven't actually written the number out for us with all the zeros first, so let's try that. What is 97.6 million? Well, 97 million would be 97 and then 6 zeros following after it. So, but I've got the 0.6, so I put the 6 next and then fill in the rest with zeros. So that's 97,600,000, which is the same thing as 97.6 million. Now I can count my decimal point moves. 1, 2, 3, 4, 5, 6, 7. So I get 9.76 times 10 to the 7th, and I see that that answer isn't up there. But that's okay. It looks like they just rounded it. So it's going to be 9.8 times 10 to the 7th. And that's a little bit of work with scientific notation.